Today we're going to be talking about rational expressions. So a rational expression is an algebraic fraction whose numerator and denominator are polynomials. And just as always, the denominator may not have a value of 0. So usually we do what is called listing those excluded values. So whatever that gives the denominator 0, you have to exclude it. So in looking at number 1, we're just going to focus on the denominator. When would m minus 6 be equal to 0? Well, if you set it equal to 0 and solve it by adding 6, you're going to get m equals 6. So that's really the restriction. You're going to say m cannot be equal to 6, because if it is, that would be undefined, denominator of 0. So that's how you go about finding the excluded values. You set the denominator equal to 0 and solve it, and then exclude those values. In this one, if we want to exclude some values, we need to first factor it. So you're going to make sure you hopefully remember how to factor. Factors of 6, they both need to be negative, notice, and they need to add to 5, so negative 3 and negative 2. So when would this equal 0? Well, when is x minus 3 equal 0? If x equals 3, so we say x cannot be 3 or 2. Those would be your two excluded values. So we're going to be simplifying some of these, kind of using the same rules that we've done with fractions about canceling and so on, or dividing top and bottom by the same number. But then we also must list the restrictions. So number-wise, if we just divide both these by 7, we get a 1 and a 3. Variable-wise, 2 of these cancel with 2 of these, leaving a to the third on the bottom. This b cancels, leaving b to the second on top. So what do we have? And don't lose your negative sign. I kind of marked it out there. We have negative b squared over 3a to the third. So that's what we get when we simplify it. Now we want to look, and it's kind of hard to look, but you do restrict from the very beginning because that was what the original problem was. So when would 21a to the fifth b be equal to 0? Well, if a were 0, so a cannot be 0, and b cannot be 0. And those would be your restrictions. So on this one, we do need to factor. Factors of 12, 4 and 3 differ by 1, so 4 and 3. Which one needs to be negative? The bigger one, so minus 4 plus 3. We also need to factor our numerator because some of these things might cancel, so x and x. Factors of 15 are going to be 5 and 3. Negative 5, positive 3. Now notice it is a multiplication, so they are factors, so the x plus 3's are going to cancel, leaving us x minus 5 over x minus 4. Can these two x's cancel? No, because this is one term, x minus 5. So that would be your simplified part. We must list our restrictions, so again we get those from the denominator. First factor x minus 4, so x cannot be 4. X plus 3, x cannot be negative 3. And even though it got canceled out, you still need to include it as part of your answer. Alright, on this one again, we want to factor first. So in the first one, the first step would be your greatest common factor. So we factor out a 3. Oops, it should be minus, not a plus. On the bottom, 5 and 2, but they're both going to be minus. So the x minus 5's cancel, leaving you 3 over x minus 2. Restrictions, x not equal to, from the first one we get 5, from the second one we get 2. And here's one that for you to try, as in class we did this one together. X squared minus 9x plus 14 all over x squared minus 2x minus 35. So again, if we're factoring the numerator, going to factor into 7 and 2, both of them minus, to give me a positive 14. In the denominator, 7 and 5. I need a negative 7 to give me a negative 2, positive 5. So the x minus 7's cancel, leaving us x minus 2 over x plus 5. Restriction, x not equal to 7 or to negative 5. And that would be it.